Hello, everyone. My name is Christos Ioannou. Before I present the last plenary talk, let me say a massive thank you to the organizers for this beautiful, from all aspects, event they put together. We all share a common passion towards economics, but our passion towards the messengers of economics is even greater, judging from the response we saw recently to the GoFundMe request. And this is even more pronounced when you consider that there were a lot of contributions, a lot of hefty contributions from fellow economists who did not even know Miltos, which is simply overwhelming. Wish you, Miltos, and all the Miltos in the world, a speedy recovery. I hope soon we will bring this beast down. As far as the logistics, if you have a question, please send it to me by private chat. And the speaker in the last 5 minutes will answer the questions, or rather as many questions as possible, given the time constraint. Without further ado, it is with great pleasure that I present the last plenary speaker of the conference, a great and creative researcher by any measure, Costas Arkolakis. Costas is the editor of the Journal of International Economics with many important contributions, especially in spatial economics. He has published extensively in the top 5. I pass the floor to my very good friend, Costas Arkolakis.
Thanks, Christo. It's an honor to be here and a great pleasure to see you. And before I start, I want to wish also again speedy recovery to Miltos. I'm sure things will be, he's a big fighter, so things will be great very soon. And again, thanks for the organizer for the honor. So this paper is joined with Federico Huneus and Eugenio Iauchi, and it's on production networks in space. So a key feature of the modern economy is the geographic complexity of production networks, and these networks are fragmented among many dimensions: countries, regions, and firms. The one common terminology many of you have heard about discussing production networks across the world is the term global value chain. And from very recently, more and more recently, people have been talking for how crucial they are for the economic success of countries. But the literature analyzing networks across countries and across space have been basically fragmented in 2 dimensions. There are a lot of work in macroeconomics that deals with production networks in space that are dealt with exogenously, so they are fixed over time, they're fixed across policies. And there's a big literature that treats networks endogenously, but only analyze the micro implications and not the macro implications. So there's kind of a limited understanding of what happens basically when endogenous formation of the networks as a result of policies result to macroeconomic changes and what are their implications. And that's what the effort will be today, to kind of unify these 2 approaches and analyze an endogenous network formation space with micro foundations in space. To do that, we will combine theory and empirics, and we will try to answer these two key questions. How do production networks endogenously arise across countries or regions? And how do macroeconomic shocks, meaning policies, endogenously shape these networks, and what are their aggregate implications? So we'll go from the policy to the micro implications aggregating to the endogenous networks and macro implications. So we will start by building a micro-founded model of spatial production networks, and where space here will be motivated by our data set on Chilean firms, will be municipalities in Chile and countries. And the firms will do 2 things in our model. We'll search for consumers and will match with other firms to provide intermediate inputs. So they will buy intermediate inputs and they will sell intermediate inputs to other firms. And this will be like the component of search and matching and the endogenous formation of networks. This model will show it has a very tractable aggregation. In particular, we can solve for like all the key objects that are in our spatial economists and macroeconomics are interested of. For example, gravity equations, as we call them, of flows from every location to another location, both at the extensive margin, how many relationships there are, and at the intensive margin. We will solve for positive properties of equilibrium, so we can characterize uniqueness, can deal with sufficient statistics for doing counterfactuals and for welfare gains. And we will also analyze the normative properties of the system, meaning what is the role of endogenous formation of space for the implications of our macroeconomic policies. And then, to kind of speak to the data, we will apply this model to rich administrative data from Chile. These are basically the universe of formal transactions in Chile. Every time that you issue a receipt in Chile, this goes to the central bank administration. It gets registered, and it will tell you what firm did it sell to which other firm. We will use this data to look at the connections of firms across space in Chile. And we will estimate the role of search and matching fictions in shaping the spatial production networks, of course, using our model. And then using the calibrated model, we will study the macro counterfactual and look at the endogenous network, how the endogenous network leads to key amplification effects. So we will find that as a result of the impact of international trade shocks and domestic transportation infrastructure, the endogenous network formation amplifies the macroeconomic implications of what was previously thought in international trade and spatial economics with models with exogenous networks. So we relate to a big literature that is active in both trade and macro and spatial economics. But one nice feature of our approach is that we can, because it's so tractable, we can use all these tools that have been developed in spatial economics the past few years to analyze the positive and the normative properties of the spatial networks, while previously these things were largely infeasible because of the non-tractability of the endogenous formation. So I'm gonna, without further ado, I'm gonna talk about I'm going to go to the Chilean data, and I'm going to talk about the main motivating facts. I'm going to be a little bit fast given the interest of time. But I will present the facts that are based on this new data set that our co-author Federico Junos is building in Chile with the rest of the team in the central bank. This is the internal revenue service data for value-added tax collection purposes. So every time you issue a receipt, basically. They cover the universe of domestic trade between all firms. This is during 2015, 2019, but we actually extend the database every day. There's more data, and we also for different aspects of the data, we have data before that too. So this will include information about the seller and buyer firm identities, the dates of the transaction, the total amounts, and the origin destination, and we can actually geocode that to the 345 municipalities in Chile, so you see where each firm is originating and where is it sending its product. And then we combine this data set with custom data that will tell us information about imports and exports, firm balance sheet data that will tell us total sales, and match employer-employee data that will tell us information about employment and wages at the municipality level. So three are the facts, and I'm going to go quickly over the second, but I'm going to focus on the first and the third. So the first one says the number of domestic suppliers and buyers is correlated with firm geographic location. This is like the population density of the location of the firm is, and firm size. So first fact basically will indicate that there's some returns to scale or some characteristic of geography that affect the firm performance and the firm network, the firm formation network formation, and that the firm size itself also determines how much the firms engage into search and matching, as it will be in our model. The second fact explains how the relationships of the supplier-buyer relationships relate to distance. And in a nutshell here, the result is that there is a strong relationship between both the extensive margin of relationship and the intensive margin and distance, a declining relationship. So there's much fewer relationships further away than there are nearby. And finally, what we find in the data is that there is a response of the network to macroeconomic shocks from abroad. So this is kind of for the interest of, say, if you want to think about the importance of global value chain, what we do is measure macroeconomic shocks that arrive to Chile because of global macro shocks, and then we see how they reflect on the domestic network of Chile. And that's kind of one fact that will lead our calibration. The fact 1 and 2 will lead kind of the model, our model selection, basically. So this is the first fact. Here is that the population density is systematically related to the average number of links that the firms have, both buyers, how many buyers the firm has, and how many suppliers does it have. So in other words, if you're in a more dense region, you have on average more suppliers than a firm that is in a less dense region, and the same for buyers. We also see, so this is how important geography is for the search and matching. In the second fact, we see how much buyers and suppliers, and customers and buyers, how they increase with the firm size. So what we see is that firms that are bigger, on average, have both more suppliers and more buyers again. So the firm size is an important characteristic for firm performance here. And that's kind of a key ingredient in the sense of modeling microeconomics in our model, right? So you want to model at the firm level the behavior of the more productive firms that will engage in more relationships and they will have more buyers. So I'm going to skip the second fact in the interest of time, but I told you in a nutshell, less relationships when we are further away, when two firms are further away. And the last fact is about how import shocks affect the performance of the firm, in particular, how many suppliers and buyers they have. So I'm going to give you, I'm going to explain two of the numbers here. We're using what is called a shift share design. We basically measure macroeconomic shocks in terms of the growth of the growth of exports of a country in a certain product, let's say steel. So like say that China is becoming exports in steel grow very fast. And then we see the share of steel that a certain firm I is using, okay, from China. So if you see that China is growing, steel sector is growing a lot, this means that this indicates that China has become much more productive. And if you were exposed to steel because you were importing a lot of Chinese steel before, that's going to be likely a positive shock for the firm. And indeed, what we see is that the firms, on average, firms that are more exposed to these positive import shocks increase their domestic suppliers and on average buy more from them. So it's as if like, they become more productive because they are more efficient in terms of buying cheaper Chinese steel or more productive Chinese steel. And that allows them to expand their domestic networks of suppliers. And also they also expand their sales. And this is something that intuitively should hold if you feel like the firm is indeed exposed to positive shocks from abroad through these global value chains. And we will use it to calibrate the model. We will, on average, our model will kind of deliver this implication that firms that are kind of in regions that are more exposed to positive shocks from abroad will expand more rapidly their number of suppliers and their sales. Okay, so guided by these facts, now we're going to present the model, which is kind of a model of firms networking in space. And the space here is partitioned by a finite number of locations. So you can call them I, U, or D. And this location could be domestic, but they could also be abroad. So it could be like a municipality in Chile trading with the United States, or trading with Cyprus, and so on. And there's a continuum of work or measure Li in its location, and W is the wages. So these are just notation. We have cost elasticity substitution preferences. And there are two types of goods. So when I'm trading, I'm either selling to final consumers in my own municipality, or I sell to a firm, a good that will become the firm's intermediate input, and in another municipality or in my own municipality, or or abroad, of course. And I have to pay a cost, tau UD, that is like a cost, it's basically an efficiency loss for shipping the good to another location. And as I said before, final goods to consumers are only locally traded. So what do the firms do? The firms reach consumers, and they also buy and supply intermediate inputs with other firms with which they match. So there is searching and matching with other firms to kind of become buyers and suppliers of intermediate inputs, and in a procedure that we'll describe next. And the firm have different productivity Z's drawn from an arbitrary distribution. So the critical bit here is that we need to characterize the unit cost of production by a firm omega in some location I. Okay, so this is how costly it is to produce 1 unit of your product. And the idea here is that the firm has some productivity, Z, but it also is producing using foreign intermediates, intermediates from all other possible firms that we will match with at the share 1 minus beta, and local labor at the share beta. Now, what is key in this model is that the share of firms that you match with is endogenous, and this is the endogenous set omega of firm small omega. Okay, so this is the firms that you will create this matching linkage, and you have to pay a cost to be able to match with them. And this, of course, are the associated price for the intermediate input that you buy. And how does search and matching happen? You pay a cost to search, and once you search, there is some matching probability to match with firms from different locations. And that will have the standard matching, search and matching technology of Diamond, the matching technology of Diamond, Mortise, and Pissarridis. So just kind of in a nutshell to explain how things work now in terms of the search and matching, the firms basically post advertisements for suppliers and buyers across locations. So this is kind of related to some earlier work I had on firms searching, and more recent work of Demir, Filler, Xu, and Yang for search and matching. And once they pay this cost, there is a search intensity, and the final search outcome would depend on some random matching by location, a la Diamond, Mortise, and Pissarridis. So how many suppliers do you match with depends on your supplier intensity and this matching probability, which is exogenous to the firm, but it depends on how much searching and matching happens in the country. And the same for buyers, but you have to pay a different cost for that. And there's a different intensity for that. So each firm, Z, in location I, basically makes this effort of finding buyers and finding suppliers, and then depending on this kind of aggregate matching Diamond, Mortise, and Pissarridis kind of matching technology, that gives you the final number of suppliers and buyers that you have with other locations, and of course with your own location. And you can only sell to people in your own country, in your own municipality, sorry. And the final bit is that the firm will charge the price, and because there's a continuum of firms, they will just charge a constant markup, as it's typical in these CS models. There's a profit per consumer that is just a constant markup over the sales to local consumers for final consumption. And the total profits of a firm, and this is a mouthful, but this is probably the most challenging part of the model, and then the rest just follows from these special conditions, is this is the net profit of the consumers, this profit per consumer times how many consumers you search, and this is your profit from the buyers. So this is how many buyers you find for your own product times the aggregate matching efficiency from location I to location D. And the C, the cost, is now determined by the cost function I mentioned before. So this will be determined by how many suppliers do you try to reach times the matching technology of suppliers times the cost of the suppliers from location U selling to location I. And these are just the costs of searching for each one of these activities, of finding consumers, finding buyers, and finding suppliers. Okay. Yeah, so all these three margins of selling and buying for consumers, for finding buyers for your intermediate input and find for suppliers that will make you potentially cheaper, will kind of give you some firm optimal problem of determining your network, the firm network across all locations, your location I and all the other locations that you sell, you find buyers, and all the other locations that you find suppliers. Okay. The solution of this problem is actually turns out to be very simple, owing to the fact that we have like CS demand and so on. But what happens here is that the number of suppliers that the firm from location I finds in location U, a firm of type Z, a firm of productivity Z, depends on this AUI, which is a function of the cost of shipping that I mentioned. So there's a function of this fixed cost of searching that I mentioned before here, these ones, right? And other parameters, but also endogenous variables in the matching probabilities. So the way to think about this is that geography here plays a role. So if geographic conditions are better, then you will have a better network, production network, and potentially more suppliers, for example, with location U. Well, maybe less with location U prime that's far away. But also, your total number of suppliers doesn't depend only on geography, but also depends on your productivity. So more productive firms here will have a bigger network, as also I showed you in fact 1. Similarly, we have for the number of buyers of the firm, or the buyer intensity of the firm, and the number of consumers. So based on fact 1, we get both, in the model, we get both the fact that geography matters, but also the fact that firm identity, firm size matters. The final bit of the model is to close the model by computing these matching probabilities that I mentioned. And the way we do it here is that we assume that the matching probability between location U and location D for suppliers and for buyers depends on how many firms. So this is the total number of firms that are searching for supplier relationships, and it's the total number of firms that engage in buyer relationships. And these are basically the aggregate intensities for suppliers and buyers. And depending on how many firms search, the total number of firms search, and then this aggregate efficiency of searching that is also determined by this exogenous parameter, then you have like a ratio of the firm that actually successfully end up having supplier and buyer matching, successful buying supplier and buyer relationships. Okay, so this multiplied by the n, the intensity of searching, will give you the final number of suppliers that you have for a given firm, and similarly, correspondingly, for the buyer firms. Now, having kind of dealt with microeconomics of the model, now we go to the macro. And the macro part requires that you solve for the number of firms, the total number of firms that sell from location U to location D, and their average sales from location U to location D. And the trick here is that when you do, like, of course, there's some kind of work there to create the final output, but it's basically some integrations and so on. And the nice thing that you're getting is that the number of firms that engage in successful relationships, the extensive margin, and the transactions per volume, the intensive margin, have this celebrated gravity form that people in spatial economics use. So all the endogenous variables are basically encapsulated in these origin and destination terms. So this zeta and this psi have is a mix of endogenous variables at the origin and at the destination. And then the bilateral terms that kind of incorporate all the information of how much, for example, distance costs and fixed costs of trade and so on affect the supplier and buyer relationships are all in this term he, the chi. So the term chi here for example, the extensive margin includes not only the iceberg cost, the cost of the cost of shipping the good, but also the fixed cost of matching both with the buyers and suppliers. And altogether, this creates a bilateral friction of creating an extensive margin or relationship between any two locations. Of course, this is aggregated across all the firms that engage in the relationship between location U and location D. And vice versa for the intensive margin, except that then the bilateral resistance term only includes the trade costs. And because, of course, that's what matters at the intensive margin. And with the elasticity of 1 minus sigma, we see elasticity substitution among groups. Now, one thing here is that distance potentially will have different effects on the intensive and the extensive margin, exactly because the fixed cost and the iceberg cost will matter different for this kind of for the extensive margin here and for the intensive margin here. Okay, so this is kind of the intuition of how we get this fact 2, where we find that distance matters for the relationship, but indeed we find that the extensive margin is much more responsive than the intensive margin. In terms of, so the extensive margin is much more responsive to distance than the intensive margin. Okay, so let me just kind of go to the general equilibrium. I have like 15 minutes and questions, right? Are there questions or?
Yes, so the last 5 minutes is for questions.
Yeah, okay, good. So I'm gonna now talk about how do we put this into general equilibrium. So basically the structural representation is I'm only very some facts of how to build a model with geography and firm size. I told you how the firms, more productive firms, engage in more relationships, but this also depends on their geographic location. And I showed you kind of this aggregation at the regional level, or at the bilateral regional level, these gravity equations. And now I'm going to talk about general equilibrium. So in general equilibrium, basically, well, everything that was before exogenous, like we took it as exogenous, like the wages and the number of relationships, will become something, an object that we have to solve for. So the search intensity kind of parameters, not parameters, but variables that you saw before that were determining how the N, the search intensity of the firm, the total number of firms that engage in relations between any two locations, the number of firms that enter, of course, the wages will be determined accordingly by equilibrium conditions of the model. I'm not going to go into details because this is kind of a lot of technicalities, but there is basically an adding up constraint. Your total sales have to include your shipments to all the other locations in the world, and so on and so forth, which with corresponding accounting relationships. And then we also solve for things like a cost shifter. For example, this CU star that would be a crucial object here is the average cost that the intermediate inputs from a location U will have. Okay, and then the D, which you show some at some point, is like total and some type of demand shifters depending on the location. This will be also endogenous solved. Okay. So after kind of a lot of a lot of pain and manipulations, you can actually write this model, even though it's kind of seems daunting to some extent. You can write as an equilibrium system of 2n equations and 2n unknowns. The 2n equation number n unknowns wages, and n unknowns, which is the cost of the intermediate inputs from location I. And this system has this characteristic form, this characteristic fixed point that many of these spatial systems have, that basically my wage will depend on all the other wages of other locations in the system regulated by a kernel. And this kernel will have, for example, information of the skies that I showed you before, incorporating iceberg costs and fixed costs and so on. So in one way to think about it is that if I trade a lot with the locations that are rich, or with locations that have very cheap intermediate inputs, that will make me efficient, that will make me richer. Of course, all this information again is incorporated in the entire network structure of the model. Yeah, and then the key thing is that these parameters K are a function of exogenous parameters including bilateral trade frictions and the extensive and the intensive margin, as I showed you before, incorporating the extensive and intensive margin resistance terms, the KAIs. Okay. One other thing is, like in most of the places in the model, what matters is that the lambda tilde, which is the lambda S, this is the returns to search intensity for the suppliers divided by the cost, the curvature of the cost for the suppliers at the firm level. And same for the buyers. What matters is lambda tilde, the ratio of the search efficiency, lambda B, and the gamma B, which is the search cost curvature. Now, a very neat particular feature of this model is that if you take the limit of these two ratios, both of them to 0, then this model collapses to the exogenous search model. Basically, search is so efficient that everyone searches at the maximum level, and the network is exogenous, right? So there's no point, there's no endogeneity, just because it's as if everyone searches everyone and everyone meets everyone. This turns out to be the standard setup in the model, in the standard setup of exogenous networks that we have in the literature. So starting with Don Cortum, variations of Caliendo and Paro, and so on and so forth. And thus provides a benchmark for us that we can compare our results to the previous literature. To understand now the normative implications of the model, by the way, sorry, one thing I forgot. Yeah, so, and we can actually prove that the system has a unique equilibrium so long that these lambda tildes are not too large. If the returns to matching and search and matching are not too strong, then the model will have uniqueness. Otherwise, if they're too strong, you have multiple equilibria because of the search externalities. Going to the normative predictions of the model, we have the following proposition that allows us to, again, compare to the benchmark with the exogenous network. We have that a given shock in the iceberg cost, in trade cost between any locations, the effect of that shock to welfare depends on the technology effect, where Xij is the mark weights, is like a total spending of the world from that region summed up across origin destinations, and an endogenous network effect that will tell you how the change in tau induce change in the extensive margin of matching. So the more of this you have, of course, the more matching is created because of the shock, the bigger the welfare gains will be. And indeed, the previous exogenous network models only have this technology effect. So anything that comes as an endogenous network effect will actually boost welfare gains, or of course decrease welfare gains, depending on the type of intervention, compared to an exogenous network model that was the representative in the previous literature. And we have extensions. We extend this model with sectors, population mobility. We have other micro foundations alternative to ours. And I think without further ado, I'm going to spend my last 7 minutes to kind of discuss how we apply this model to data. And of course, as long as no Chilean gets upset that I flip the countries so they can fit it. This is Chile, and this is kind of the actual production network we have through Chile, where the bubbles is the population size, and the color from red to blue is how much trading there is between municipalities in Chile. First of this, do I have 10 more minutes, 5 for questions, or only a few minutes?
5 minutes, and then another 5 minutes for the questions.
Okay, yeah. So I timed it right. Okay, good. So this is basically the information we will put into the model, and suffice to say, we can, if we have this information, that's all we need to do counterfactuals in our model using some of the techniques in spatial economics. I'm gonna take this as given. Then we use this 345 municipalities data we have. We also use data from foreign countries. We exactly match these bilateral trade flows, the one I showed you, for both within Chile and Chile to the world. We assume a labor share in production of 20%. And we estimate the structural parameters, the lambda tildes and the sigma, using this fact 3 that I showed you, which is how much firms respond to positive foreign shocks of cost shocks. So China grows, you become more productive. How many more firms do you reach domestic? And we impose the sufficient conditions for equilibrium uniqueness for our estimation. We decompose the bilateral trade frictions into search and matching frictions and iceberg cost. And indeed, we can, in our model, we can kind of separate the two. We can separate the intensive margin friction and the extensive margin friction. And I'm going to show you how this works in the data. I'm going to skip the model, but we actually have a pretty good fit, though we are changing the estimation. We have a pretty good fit to the fact 3 that I mentioned. So this is a picture of the estimates of iceberg and search and matching frictions. So this is, we estimate the iceberg cost friction between any two municipalities, and then we plot them. So this is the density on the x-axis, the probability on the x-axis, and the y-axis, and the x-axis is the magnitude of the friction. And what you see is that, in fact, the iceberg cost frictions are basically much smaller, but somewhat a bit more dispersed than the search friction. So the search friction, which were like kind of largely ignored in the literature, though there are some recent papers that now estimate them, including, of course, ours, turns out to be bigger than the traditional iceberg cost frictions that people have been using to estimate the kind of the cost of moving goods across space. So we're going to do two counterfactual scenarios based on this data and this calibration we do. The one is the international trade scenario, where we will look at a change in the trade cost and the domestic implications in Chile. And the second is the domestic transportation infrastructure, where we will simulate the building of which is under construction or almost done, of the biggest bridge in Latin America that connects the biggest island in Latin America to the mainland of Chile, the Chiloé Island mega bridge. And we will see the welfare implications and how these welfare implications kind of space out across Chile. We'll use our baseline, but we'll also do the extensive margin, no extensive margin model, which is the benchmark in the literature. And remember, our model, if you assume the same sigma between our model and the non-endogenous network benchmark, our model will have more response in trade because of the extensive margin response. So, so that's kind of, we have to recalibrate our model sometimes to compare with the benchmark. So our model has a bigger response of trade, all else equal, but we have to recalibrate sigma to create the same response. So this is the first counterfactual. It's a 10% reduction in iceberg trade cost from Chile and to Chile from different locations, from China, Germany, and USA. And in our baseline model, the one we calibrated with the endogenous network, we get that the 10% reduction in iceberg cost with China creates a 1.53% welfare gains for Chile. And that's much bigger, of course, for the corresponding change with Germany, because China has already very big relationship with Chile, as is also US. So like with a bigger trading partner, you get bigger gains. The gains are bigger versus variations of the no extensive margin model. In fact, the gains are bigger, even though in this variation of the no extensive margin model, the changes in trade flows are the same as our baseline, because we have sigma 5 in the no extensive margin that increases the elasticity of trade, while in the baseline we have sigma 3, but we have a higher endogenous response of trade, as I mentioned. But between these two versions, the trade flows are basically responding the same way, and our model has bigger welfare implications because of this term I showed you before, that creates an endogenous network effect. Okay, so that gives an additional kick to the welfare gains from openness. And then the last counterfactual, I'm going to close to that, I think hopefully right in time, is the planned opening that is going to happen very soon of the largest suspension bridge in South America, that will shorten the travel times to the mainland from 35 minutes that's currently to just 2 minutes. So we basically measure the trade costs within Chile with the municipalities, and we make our model fit that, and then we make the change from the current to the counterfactual, which will be factual soon, of course, the mega bridge, and we simulate the change in the trade cost because of that. And what we find is that there is a gain of 0.20% as a result of this, which is kind of pretty big if you think this is one construction inside Chile. But what is very interesting is that there are very different direct and indirect effects across municipalities. The municipalities that are trading a lot with the Chile island will get a huge boost in their welfare, because now they can trade very much more efficiently. They don't have to put in the boat, pay much more money for the shipment, but they will have kind of direct access. And then there are both direct effects and indirect effects from this experiment, meaning that the spillovers also spill over across space. That's the indirect effect. Municipalities that are further away from Chile island have smaller gains, but they have somewhere benefited through the spatial effects as a result. Okay, so that was it. I think hopefully right on time. So what do we do? And we are still working on the paper to wrap it up. So we'll be changing calibration and so on. But in principle, we analyze the organization of endogenous production networks in space by using a micro-funded model. And we use this rich Chilean data to discipline the micro and kind of investigate the macro implications. Okay, and thanks very much for the opportunity.
Thank you, Costa, for this eloquent presentation. So let me open the floor to questions.